So we have already used the break statement when we were using the switch case labels. I'm going to talk a little bit more about the break statement now. And together with it, I'm going to talk about another statement called the continue statement, which we have not used yet. Now, the break statement can be used inside principally four structures: the while loop, for loop, do while loop, or switch statement. What it does is when you put in the break statement someplace, it'll take you out of these structures. In the case of the for loop, it doesn't matter if you have any more iterations that you could have executed according to the increment and condition that you have in the for loop. Once you call break, once you reach the break statement, it'll take you out of the for loop. You can do the same thing for inside a while loop or do while loop, and we've already seen that being used in the switch statement within or after the code for each case. So basically the break statement lets you skip over the remaining code in a loop and takes you out of the loop. So as an example, let's take a look at a for loop, and inside that for loop we'll have an if condition, and that if condition will check if a certain variable x has taken on the value 5. If that becomes true, the break statement is executed. Now, regardless of how many more iterations the for loop had planned, once the break statement is hit and executed, that'll be the end of that for loop. So here's the code for that. So as you can see, we have this unsigned integer x, and if you look at the for loop, x is initialized to 1 and is incremented by 1 in each iteration and should run for 10 iterations if you just look at this one line over here. So the condition for continuation is that x stay less than or equal to 10. So that would ordinarily mean that we run this for loop for 10 iterations. But inside the for loop, we have this if condition. And if x becomes equal to 5, we execute the break statement. Otherwise, the value of x is printed out to screen using the printf statement. And outside of the for loop, we have another line of code that says printf broke out of for loop at x equal to whatever the value of x is. If we run this code, what we'll see is this: 1, 2, 3, 4 are printed out by line 17 of this code. But when x becomes equal to 5, this if condition inside the for loop turns true. We hit the break statement and we jump out of the for loop to this last printf statement, which produces this second and last line at the output: broke out of loop at x equal to 5. X equal to 5. That was the break statement. Now let me talk about this new continue statement. The continue statement is also used to end a loop prematurely, but not quite like the break statement. When you hit the continue statement, you do not exit the loop entirely. Instead, you do skip over the rest of the code inside the loop body, but you do not exit the loop. Instead, you go to the evaluation of the continuation condition. Basically, you jump to the next iteration of the loop and you check if that next iteration should be executed or not. Otherwise, the continue statement is used in the same places as, or much of the same places, except not in the case statement, but it's used in the while loop, for loop, or do while loop. And like I said, this continue statement only skips the remaining statements in the body of the loop, and takes you to the next iteration of the loop, not outside the loop like the break statement does. And to demonstrate that, let me show you some sample code. Basically the same example that we just saw for the break statement, but we're going to replace break with continue over here. Otherwise, it's the same program. Only other thing that we've changed is we've moved the definition of X into the for loop. And the reason we did that, or we could do that, is because we are not printing out the value of X over here. We don't need the value of X outside of the for loop. Could have left that as it was, but just something you should understand. Okay, so what will happen here is that X again is initialized to 1, is incremented by 1 in each iteration, and the continuation condition is still the same. X has to be less than or equal to 10. And if X becomes 5, we hit the continue statement. And like I said, what that does is it skips over everything that's in all the statements inside the loop and takes us back to the next iteration, or takes us forward, I should say, to the next iteration of the loop. In this case, when X is equal to 5, we skip over the print statement, we go back up here, X is incremented to 6, and we keep going through the loop, which means we will run 10 iterations of the for loop. Sometimes this is what you need, and that's when you can use the continue statement. If you run this code, this is what the output will look like. 1, 2, 3, 4. 5 is not printed out because we skip over that due to the calling of the continue statement. And we skip over 5 and we print out 6, 7, 8, 9, 10. And in this sense, we used the continue statement to skip over printing the number 5. Now, one view of the break and continue statements is that they violate structured programming norms. Nevertheless, the break statement is kind of essential if you want to use the switch statement, switch label. There are alternatives. You can, if you want to break out of a loop, there are other ways of achieving that. Let me also briefly talk about something we already covered before, a little superficially, and that is logical operators. So I already talked about what if we did some hands-on demos for that. If you want to combine different conditions, be it in an if block or in a loop as a continuation condition, but I already showed you how to use the logical AND operator and the logical OR operator. There's one more that you should know about that you've kind of already seen, and that is logical NOT. So I'll run through this briefly. So I'll just add this about logical NOT. If you have a certain condition which is evaluating to true, if you put the logical not operator, which is an exclamation mark, if you put that in front of it, true becomes false. And if the condition happens to be false to start with, the not operator, logical not operator, will convert it to true. It'll just flip true to false, false to true. It's also called logical negation. Okay, so this is kind of one example use of logical AND. So if some variable gender is 1 and age is greater than 65, you want to, for example, increment a certain variable. Just jump ahead. So let's have two expressions. One happens to be false, the other one is also false. Then if you put an AND, a logical AND symbol in between, the result will also be false. If one is false, the other is true, and you combine them again with a logical AND, the result will still be false. If the first one is now true and the second one is false, combine them with a logical AND, the result will still be false. Only when both are true and you combine those two expressions with a logical AND will the result be a 1 or a true. Then we have the logical OR operator, which let's say over here in this example, we have one variable semester average. Let's say that is if that is greater than or equal to 90, and the final exam score is also greater than or equal to 90, then student, let's say, gets an A grade. Let's say that's our condition. So if one or the other has to be true for the student to get an A grade, you can combine those two conditions using an OR operator. This table that we just saw also has a name. This is called, for logical operators or logical expressions, this is called a truth table. Basically, in this example, we're using it to explain the operations that, or actually all the possible cases that can arise for all possible sets of inputs, and what the corresponding output will be for these logical operators. So in the case of OR, if both expressions happen to be false, the combined expression combined using the logical OR operator will also be false. If one is false, the other one is true, the combined expression combined by OR will be true, will be a 1. If the first one is true and the second one is false, still the same thing. And even, of course, if both are true, combine them with an OR, the result will also be a 1 or a true. And finally, there's the logical not operator. So let's say condition like this one that you see over here. If grade equal to sentinel value not, if that is not true, then next grade is blah blah. Execute the next line. So basically, if your expression is false, you put a logical not operator in front of it, the value becomes true. If the value is true or non-zero to start with, you put a logical not operator in front of that, the new value becomes false. And you can, of course, combine different logical operators together like that. Finally, like with all operators, we have to fit them in somewhere, or they do fit in somewhere in the order of precedence, in the order in which they are evaluated. And it happens to be not, this is not's place, this is and this is or's place. Associated with logical operations is the Boolean data type, which we have already played with. If you would like to use the values true and false in conjunction, and you would like to use this data type, the Boolean data type, for which we use the keyword bool. You have to include, if you want to use that in your code, you have to include the standard boolean library, or stdbool.h header file. Finally, one last addition about the difference between, I hope by now this is clear. When you're comparing values, please use the two equal signs. That's the comparison operator. When you want to change the value of a variable to that of some other expression, or just a direct value, use the assignment operator. Comparison operator uses two equal signs. Assignment operator is a single equal sign. The result of comparisons is true or false. The result of an assignment is a change of a value of the variable you have on the left side. And over here on the right side, you can have really any expression, and that will be assigned to the variable on the left. So please make sure you know this. Don't get confused between the two.